Hello, good evening students. Welcome to GTC classes. Hope you all are doing well and your preparation for NIPA 2025 is going great. Students, this is the time you all have to work very hard and stay focused. So, without wasting any time, let's start with today's video lecture of medicinal chemistry on cholinergic nervous system. So, let's start. Before starting cholinergic nervous system, let's have a brief introduction on the nervous system of our body. So basically the nervous system of our body is divided into two parts, that is the central nervous system and the peripheral nervous system. Central nervous system, it basically covers the brain and the spinal cord. And peripheral nervous system, it is basically responsible for this attachment of this brain and spinal cord with the rest of our body. Okay, now the peripheral nervous system is basically further divided into two parts, that is the autonomic nervous system and the somatic nervous system. Autonomic nervous system, all the involuntary movements in our body that are controlled by the autonomic nervous system. Involuntary movements like the respiratory rate, then the digestion, urination, heart rate. All these involuntary movements are controlled by the autonomic nervous system in our body. Then somatic nervous system, all the voluntary movements are controlled by the somatic nervous system, like the skeletal muscle movement. Under skeletal muscle movements like the movement of our head, hand, movement of our neck. So all these voluntary movements are controlled by the somatic nervous system. Now, autonomic nervous system is further divided into two parts, that is the parasympathetic system and the sympathetic system. Now, parasympathetic system is basically responsible for the rest and digest condition. So, when the body is at rest and digest condition, then the parasympathetic system works, and second is sympathetic system, that is fight and flight system. So basically when our body is fight and flight or very active, then that time the sympathetic system works. So parasympathetic system is basically divided into two parts, that is the cholinergic system and the anticholinergic system. Then sympathetic system is also divided into two parts, that is the adrenergic system and the antiadrenergic system. Now let's move forward towards the cholinergic drugs or parasympathomimetic system drugs. Parasympathomimetic drugs. Now what do we mean by this word? Here mimetic. Mimetic means to mimic. So here what we are mimicking? The parasympathetic system. We are mimicking the parasympathetic system. So cholinergic drugs are the drugs that mimic the parasympathetic system. The compounds that mimic the action of acetylcholine. So acetylcholine is the neurotransmitter in the cholinergic system. So compounds that mimic the action of acetylcholine, and these produce the cholinergic nerve stimulation. Now, synthesis of acetylcholine. Acetylcholine is basically synthesized in the cholinergic nerve ending. So this is basically the nerve ending. So at cholinergic nerve ending, basically the synthesis of acetylcholine takes place. Now serine is an amino acid that is the precursor for the synthesis of acetylcholine. Now in the presence of an enzyme serine decarboxylase that removes this carboxyl group in the form of carbon dioxide to form 2-amino ethanol. Now, this 2-aminoethanol in the presence of an enzyme choline and methyl transferase, it forms choline. Now, what this choline and methyl transferase do? It catalyzes the transfer of methyl group to the choline. Now, as we are saying that we are transferring the methyl group, so from where we are getting this methyl group to transfer? So this S-adenosyl methionine, this is responsible for the, or this is the donor of methyl group. So the methyl group that is donated from the S-adenosyl methionine, that are transferred by the help of enzymes choline and methyl transferase to form choline. Now this formed choline, it reacts with acetyl coenzyme A. Now this acetyl coenzyme A, from mitochondria we get it. So from mitochondria we get acetyl coenzyme A. It reacts with choline that is formed above. How it is formed? Now in the presence of enzyme choline acetyl transferase, it forms acetylcholine. Okay. Now synthesis, storage and destruction of acetylcholine. Now choline is basically that is found in our body, that is present in our body, or that is made or manufactured in our body itself in liver. During the phospholipid metabolism, choline is synthesized, but this choline is synthesized in a very small amount, so the need of our body is not fulfilled by that choline that is being synthesized in liver. So we need some external medium for this choline. So from dietary source we get this choline, plus from the liver during the phospholipid metabolism. So this choline, it reacts with the acetyl coenzyme A. The acetyl coenzyme A, I already told you that we get it from mitochondria. These combine together in the presence of this choline acetyl transferase enzyme to form acetylcholine. Now this acetylcholine is stored in the synaptic vessel till we don't have its use. Now when there is an action potential, so now there is an action potential, so we need acetylcholine. So this action potential allow the calcium influx towards this synapse. So in this due to this calcium influx, this synaptic vessel, it get breakdown, and due to its breakdown the acetylcholine is released, and after releasing it binds to the receptor of acetylcholine and give its action. Okay. Now SAR of acetylcholine, or we can say structure activity relationship of acetylcholine. So before studying the SAR of acetylcholine, let's have a look on the structure of acetylcholine. So first is the acetoxy group. We have acetoxy group in the acetylcholine structure. Then we have a ethylene bridge. Then the quaternary ammonium group. Okay. So the acetylcholine basically contain a acetoxy group, ethylene bridge and quaternary ammonium group. So now SAR of acetylcholine. Now first we will see this quaternary amino group, only the modification in this quaternary amino group. So what impact will it have if we modify this quaternary amino group towards the action, towards its cholinergic activity? Okay, so for the optimum activity, this amine group must be quaternary. So this quaternary amine group is very important for the activity of this cholinergic activity of acetylcholine. So if we replace this quaternary amine with primary, secondary or tertiary amine, then it will result in a less active compound. So here are the example of some drugs that contain this quaternary amine ammonium group in its structure. Like first is acetylcholine, then methacholine, carbachol, methanocol, all these have quaternary amino group in their structure. Now, if any of these methyl group in acetylcholine is replaced by ethyl or larger group, it produces a less active or inactive compound. So, in this quaternary amino group, if this methyl group, if we replace this methyl group with ethyl, or we say propyl, or any larger group, then it will result in a less active compound. Okay, and then if we substitute all three methyl group, like here we have an example, if all three methyl group will be replaced by some other alkyl, like it can be ethyl, it can be propyl, if we replace it by any other group other than methyl group, then it will result in the antagonist activity at cholinergic receptor. So it will start acting like an antagonist to the cholinergic receptor if we replace all three methyl group to the higher alkyl groups. Okay, it can be any higher alkyl group. Now, replacement of this nitrogen by any other atom result in a less active compound. So, this nitrogen is also important for the activity. So, if we replace this nitrogen with any other group, then it will also be responsible for the decrease in the activity of this decrease in this cholinergic activity of that particular drug. Okay. Now, modification in the ethylene bridge. Now we are talking about this particular ethylene bridge. So if we increase or decrease in the chain length of this ethylene bridge, then it will result in the decrease in the cholinergic activity. Okay. Now acetylcholine is non-selective. So what do I mean by non-selective? Non-selective means like this cholinergic system, if we talk about the cholinergic system, it basically has two receptors. One is nicotinic receptor and second is muscarinic receptor. So acetylcholine is non-selective as it acts on both the nicotinic receptor also and muscarinic receptor also. So acetylcholine show its action on both the receptors. But if we substitute this methyl group at alpha carbon, so in this acetylcholine, now this is the alpha carbon and this is the beta carbon. Now if we substitute this alpha carbon with a methyl group, then this acetylcholine structure, now not an acetylcholine structure, but this acetylcholine structure will be selective towards the nicotinic receptor. And if we if in the place of alpha carbon we add a methyl group at beta carbon, then it will be selective towards the muscarinic receptor. Okay, so due to a small change or small addition or small substitution of a methyl group, we have a totally different advantage. Okay, now here, like acetylcholine, this is a non-selective cholinergic agonist. I have already told that. Now this is methylcholine. The drug name is methylcholine. So in this methylcholine, this is nicotinic agonist and nicotinic selective. So nicotinic receptor agonist selective, as it has a methyl group at alpha position, methyl group at alpha position, alpha carbon. Then at beta carbon, if we attach a methyl group, that is the drug will be called as methacholine, then it will be a muscarinic receptor selective. Okay. Now substitution of alkyl group to other than methyl group at alpha or beta position decreases the activity. Now substitution of any other alkyl group other than methyl group, it can be any, like ethyl, propyl, butyl, so it will result in the decrease in the activity. Okay, only methyl group will increase the activity, but any other substitution at alpha or beta position, it will result in the decrease in the cholinergic activity. Okay, now modification in acetoxy group. Now this is the structure of acetylcholine, so this is the acetoxy group. So if we make any changes in this acetoxy group, what effect will it have in its cholinergic activity? Now substitution of amino group in the place of this methyl group, it will increase the cholinergic activity. So this methyl group, if we will replace this with NH2, or we can say amino group, then it will result in the increase in the cholinergic activity. Like we have an example here, like carbachol and bethanocol. These are the two drugs which have amino group in the place of the CH3, and they are more potent than acetylcholine. Now second is substitution of acyl group with aromatic or higher molecular weight esters make the molecule antagonist at cholinergic receptor. So addition of aromatic or higher molecular weight groups, it will result in the molecule with antagonist activity towards the cholinergic receptor. Okay. Now classification of cholinergic drugs. Cholinergic drugs are basically divided into two types, that is directly acting and indirectly acting. Directly acting, these drugs act directly at the receptors of the cholinergic system or cholinergic drugs receptor, they act directly on its receptor. But when we talk about indirectly acting, they are also called as anticholinesterase drugs. So they don't act directly, but they show their action by some alternative means, like they can increase the neurotransmitter at a particular position, or neurotransmitter release. They can increase the neurotransmitter release, or they can decrease the breakdown of the acetylcholine at that particular place. So by like these alternative methods, it can act, or it can help in increasing the acetylcholine at a particular place. Means they don't act directly on the receptor, but by some alternative means it is doing the same work as the directly acting drugs or as a cholinergic drugs. Okay, now directly acting is basically of two types, that is cholinester and alkaloids. So cholinesters, they are acetylcholine, methanocol, carbachol. Alkaloids, pilocarpine, muscarine, ericholine. Then indirectly acting, they are basically of two types, reversible and irreversible. Now reversible are of two types, lipid soluble and water soluble. Now these lipid soluble drugs, as they are lipid soluble, then they can easily cross blood-brain barrier. So as they can cross blood-brain barrier, so these drugs, not all, but these three drugs, they are very widely or very commonly used in the treatment of Alzheimer's disease. Okay, as they are lipid soluble and can cross blood-brain barrier. Then water soluble drugs, neostigmine, pyridostigmine, and troponin. Then irreversible means their action can't be reversed. So they are organophosphates and carbamates. Organophosphates, they are basically the nerve gases, and They are used as insecticides, pesticides. Okay, and then malathion, parathion, and others. Then carbamates, carbaryl, propoxure, LD-carb. All these are carbamates or irreversible or indirectly acting cholinergic drugs. Now, directly acting drugs. Let's study the structure of all the drugs. So first we will start with directly acting drugs. They bind with cholinergic receptor and activate them. So directly acting, I already told that they act on cholinergic receptors. Okay. Now first is acetylcholine. So as we have already discussed the structure of acetylcholine, but still, so the structure of acetylcholine is very simple. We have a acetoxy group, we have a ethylene bridge, and we have a quaternary amino group, ammonium group here. So this is the structure of acetylcholine. Both quaternary amino group and acetoxy group, they are joined by the help of the ethylene bridge. Okay. Now methacholine. So from the name, we can learn its structure. So methacholine. Metha means methyl group, choline means acetylcholine. So the structure of methacholine is almost similar to acetylcholine. The difference is here at beta position. At beta carbon, we have methyl here in the structure of acetylcholine, so that is called as methacholine. So just here we have to add a methyl group, so it will be methacholine. Okay. Now carbachol. In carbachol, again with the help of a name we will draw a structure, learn a structure. So carbachol. Col here is we can say its structure is almost similar to acetylcholine. Sorry, the structure is incomplete. So here N positive CH3. So quaternary amino group and the ethylene bridge, and here the group. So in acetylcholine we have a acetoxy group here, but in carbachol, in the place of this acetoxy group, we have a carbamate group. So what is this carbamate group? O, C, double bond O. Instead of CH3, we have NH2. So when this CH3, we replace it with NH2, this group, this acetoxy group is now called as carbamate group. So this is a carbamate group. Okay. So carbachol. Carba means carbamate. Instead of acetoxy, we have carba group, and then as it is, the acetylcholine structure is there. Okay. Almost similar to acetylcholine only. Then bithanocol. In bithanocol, this structure is almost same as carbachol. Just the difference is that at beta position we have a methyl group. Okay. So here, easy. Now alkaloids. So alkaloids, as we already studied in pharmacognosy, that alkaloids are the compounds or that basically contain, that have a basic nature, and as they have a basic nature, so mostly they contain nitrogen in its structure. Okay, all the alkaloids, not all, but mostly all the alkaloids have nitrogen in its structure. Some exceptions are there, but mostly all of them have nitrogen. So first is ericolin. So here ericolin. So ericolin, it is isolated from the seat of Erica catechu. It is non-selective. Okay, it is basically used in veterinary practice. So ericolin. So from its name we will learn its structure. Eri. From air we can say aromatic. So as we can see, this structure is not aromatic, but basically aromatic are rings. So this has a ring. So by AR we can say ring, aromatic ring. So aromatic ring, we have a ring. So we have a ring here, and as it is an alkaloid, so it contains a nitrogen. So we have a ring and a nitrogen. From Eri, a ring, as it is an alkaloid, so we have a nitrogen here. So with the help of this trick we can simplify, or we can just learn, or we can memorize the structure of this 𝘂𝙧𝘾. Okay, then muscarine. Basically muscarine is a fungus and mushroom is also a fungus. So this muscarine, it looks like a mushroom head, this head of a mushroom. Its structure looks like a mushroom with an oxygen tail. It has a tail, it has a head of a mushroom with an oxygen tail as oxygen. So muscarine, and it has a quaternary amino group. Okay, then pilocarpine. Pilocarpine, it is an important structure. Okay, so dihydrofuran and imidazole. It has two rings that are attached by the methyl bridge. Okay, pilocarpine. Then indirectly acting drugs. These drugs basically inhibit enzyme cholinesterase that prevent the breakdown of the acetylcholine. Okay, then as the acetylcholinesterase is prevented, so there will be no breakdown of acetylcholine, and it will result in the excess of acetylcholine. Okay, so physostigmine. So we will start with neostigmine. Okay, so neo means new, Benz car, N plus. Okay, so N plus is the name of a new Benz car. So this is the trick by which we can learn its structure. So Benz, here Benz means we have a benzene ring here. N plus means we have a quaternary amino group here. Car means we have a carbamate group here. So I have already told you what is carbamate. In acetoxy group, in the place of CH3, if we have NH2, that is called as carbamate. So benzene, NH2, quaternary nitrogen, then car, we have a methyl carbamate here. Okay, and C double bond O N. Okay, instead of NH2 we have CH3, two CH3 groups here. So methyl carbamate we have. So by this trick we can learn the structure of neostigmine easily. Okay, now physostigmine. Physostigmine is its structure is almost similar as neostigmine. Physostigmine, we get it from natural means. Okay, so in physostigmine also we have a benzene ring and we have a methyl carbamate group. Okay, then we have a pyrrole rings too. Okay, so we can learn physostigmine structure also very easily by the help of neostigmine structure. Then third is pyridostigmine. Pyridostigmine, by the name we can say pyridine. So it has a pyridine ring and it also contains a carbamate group, methyl carbamate group. Okay, then hydrophonia. Fourth is hydrophonia. So by its name we can see phonium, O, pH, phenyl ring. So we have a phenyl ring here, and remember one thing, students. If in any name you have IUM at the end of its name, then it means that its structure will contain quaternary ammonia. Okay, so here we have am, so we have a quaternary, we will have a quaternary ammonium in its structure. Then pH, from pH we can learn that it has a phenyl group. Then here we have OH, so by OH we can say that OH group is also attached here, so hydrophonia. Okay, now donepezil. In donepezil, it is used in the treatment of Alzheimer. It is a lipid soluble drug, as we already discussed during discussing the classification of these cholinergic drugs. So it can cross blood brain barrier very easily, so it is used in an Alzheimer treatment of Alzheimer disease. Okay, so its structure, it contains indene and pyridine. So here piperidine. So here piperidine, it is attached by a methyl bridge and indene in its structure, donepezil. Okay, now tacrine. It is an acridine derivative, tacrine. So its structure is also similar to acridine. So the structure of acridine is very simple. Okay, we basically have 3 rings, and so this is the structure of tacrine in acridine. And in the structure of acridine, if we attach NH2 here at this position and we remove the double bonds from this ring, then this is the structure of tacrine. Okay, so from acridine you can learn tacrine. It's a very simple structure. Then organophosphates. These are the irreversible acetylcholine drugs. Okay, so as the name suggests, these are organophosphates. Organophosphates means organic compounds. So organo means organic compounds, and phosphates means then that it will contain phosphate group in its structure. So let's see, malathion. So in malathion, as it is an organophosphate, so it will contain a phosphate group. Then we have thi. Thi means sulfur. So here we have sulfur in its structure. So malathion. Now malathion, the structure of malathion we can learn organophosphate, we have a phosphate group. Thion, we have a thio group, that is sulfur. So it is also very simple to learn. Remember, it is very simple to remember the structure of malathion. Then parathion. By parathion we can say it is also an organophosphate, so it will also contain a phosphate group. So here is the phosphate group. Para means para position. So at para position we have both the substitutions. So thion, para, thion. At para position we have both the substitution. Benzene ring. At para position we have phosphate. At para position we have NO2. So how we can learn NO2? ON, NO, ON. So we can say from ON we can learn NO2. So in the structure of parathion, as it is an organophosphate, it will contain a phosphate group. At para position, both the substituents, one is NO2 and one is phosphate. Okay, so parathion. Simple. Then ecothiophosphate. So in 𝑒𝑐𝑜𝑡₄𝑖𝑜phosphate, again it is an organophosphate, so it will contain a phosphate group. Okay, then it also contains a quaternary amino group, and thio, it contains sulfur. So 𝑒𝑐𝑜𝑡₄𝑖𝑜phosphate, it also has a simple structure, as it is an organophosphate, it contains an phosphate group in its structure. Okay, now carbamate. As these are carbamates, now in organophosphates we have phosphates in our structure. Now this is carbamates. So in carbamates we will have a carbamate group. So what is in carbamate group? OCONH2. This is in carbamate group. So in carbamates we will have a carbamate group in its structure. So here is a carbamate group, here is a carbamate group, then here is a carbamate group in all three structures. So first, carbaryl. So in carbaryl we have a carbamate group here. These carbamates, I have already told you that these are used as insecticides and nerve gas for chemical warfare. Okay, then propoxure. From propoxure we can say propane. So okay, so what does a propane mean? Propane means 3 carbons. Okay, so here we have 1, 2, 3. So propoxure, we have 3 carbons. Okay, it has a as it is an carbamate, so it will have a carbamate group. So here is a carbamate group. Okay, it is also used in insecticide and nerve gas. Okay, then LD-carb, it is also used as an insecticide and nerve gas. So it also contains a carbamate group in its structure as it is an carbamate. Now, common uses of cholinergic drugs. Basically, these cholinergic drugs are used in the treatment of myasthenia gravis, in the diagnosis of myasthenia gravis, in Alzheimer's disease. I have already told you the lipid soluble drugs, those are used as they can cross blood-brain barriers, so they can be used as Alzheimer's disease, treatment of Alzheimer's disease. Then insecticides, the carbamates, all the carbamates, they are organophosphates, they are used as insecticides. And fifth, we can also say as nerve gas, not used but they are also used as nerve gas, then insecticide. Okay, so thank you so much. Hope you liked the lecture. Thank you.